right, so I just wanted to hop on and make a little video talking about this paper that I found yesterday. That was really interesting. It came up in the context of protein needs in pregnancy. And first of all, my house is really loud, so it just always is. So there's no good time to make a video, but we're just going for it anyway. Um, the context of protein in pregnancy is something that I have been researching for a couple of years and am really interested in because it's super understudied, and the reason for that being that um, all kinds of things are understudied in pregnant populations. Um, Review boards and research committees are barely ever going to approve any studies on pregnant women. And that's because the perceived risks outweigh the perceived benefits. And it's just a risk that different review teams don't want to take on. And so there is a huge lack of actual intervention studies on pregnant women. And it's not surprising that there's a lack of information on protein restriction because there's enough knowledge regarding the importance of protein um, to know that uh, doing an intervention trial on protein restriction um, could cause some serious problems. But what's so cool about this paper is that it provides an alternative to a human study, and that is looking at non-human primates, which is so interesting. And I have to admit that I didn't think of this. I've been looking at animal studies for a long time. There's lots of rodent models of different dietary factors as they relate to pregnancy, but it makes a lot of sense to look at primates, right? There's going to be more homology to human gestation, human placental function. Even though most of these mechanisms are pretty evolutionarily conserved, not every species is going to have the same dietary needs. And obviously, the non-human primates aren't going to have exactly the same needs, but I think that there is enough homology here in the genome and everything to where we really can draw some we can draw some analogies between what we're seeing in this study and what we might expect to find in human pregnancy. We'll just get right to it. This is published in Nature, and the relevance of that is just that it's a prestigious journal, which hopefully speaks to the quality of the science, hopefully, but definitely to the importance of the topic. It was published this month in January 2023 and titled Impaired Placental Hemodynamics and Function in a Non-Human Primate Model of Gestational Protein Restriction. So they had 3 different arms. Each arm had 8 primates. And so the first was the control, and it was fed 26% protein. Then we had 33% protein reduction, which was a 17% dietary protein, and a 15% reduction, which was 13% protein. And so just stopping right here, 26% protein in human guidelines, that is considered a high protein diet. The way that we would kind of translate that would be say that you were an average sized woman, 140 pounds. If you did double the RDI, recommended intake, which would be 1.6 grams per kilogram of protein, 1.6 grams of protein per kilogram of body weight, lean body mass. There's a few different ways to define that, but that would be considered high protein. And for a 140-pound woman, that would come out to about 100 grams of protein a day. That's double the RDI. So the RDI is 0.8 grams per kilogram. So for average size 140-pound woman, that would be 100 grams a day. Okay, so that's the human context. Okay, what about primates? What's like normal for them? Is a 26% protein diet a normal primate diet? It's hard to find information on this, okay? So I went to the Merrick Vet Manual, and it said for North American primates, what we're looking at for average protein percentage of diet, it would be somewhere around 18 to 22% considered optimal. So what we're looking at in this study is actually above optimal, what is considered optimal range for this species, which I think is pretty interesting. Okay, so then what we see in the intervention arms, 17%, and then 13%, those are really more in line with what the RDI would be for a human, right? So somewhere around 13% of calories as protein. So let's keep that in mind as we review what the results were. So I'll go a little bit into the details of the study, but really I'm just wanting to read the abstract here. So the big finding here was that in the control arm, the pregnancy loss rate was 0 of 8. So all primates in the study got pregnant. They were able to achieve pregnancy. In the control arm, 0% of the control primates lost their pregnancies. But 1 of 8 primates lost their fetus in the 33% reduction arm. In the 50% reduction arm, 3 of the 8 mama primates lost their fetuses during the intervention. And that is incredible. So, wow, wow. That's a lot of loss, right? So obviously, we know that's not happening at that rate with human pregnancies. 3 of 8 is pretty significant. That's not happening, but what we know is happening in human pregnancies is a high degree of high risk pregnancies complicated by preeclampsia, gestational diabetes, intrauterine growth restriction, of course, small percent of stillbirth, and other complications. See, yes, my house is loud. We're just going to keep going. So the other thing that they looked at was they used MRI to explore placental blood flow. And what they found was that in the second and third trimesters, they noticed a marked decrease in placental perfusion in the protein reduction arms. And so there's a mechanistic reason for that. There's lower nitric oxide, there's lower signaling for angiogenesis, which means blood vessel formation. So there's various reasons behind why we might see the lower perfusion of the placenta. But what I thought was really interesting to look at and really painted a very clear picture was looking at these histograms um, for the placenta. And what we see here is the control placenta. We see bigger size, a lot of good perfusion, what we want to see with a normal, um, well developed placenta that is transferring nutrients to the conceptus. However, what we see with the 50% protein reduction is a much smaller placenta and clearly less effective blood perfusion in that placenta. So, anyway, I thought this study was pretty interesting, pretty significant in terms of what kind of studies I like to look at. And there are a lot of things that we can piece together regarding what the optimal range of dietary protein is in pregnancy. And all of that is in conflict with what the current RDI is. There is no established RDI for pregnancy, so one would just have to look at the adult RDI for protein, which is currently set at zero point 0.8 grams per kilogram. What that looks like is about 50 grams of protein a day. That's the standard American diet at best. So it's a sure thing that most people are eating somewhere around that range, possibly less depending on their income. Definitely with the increased cost of cheap protein sources like eggs, we could see an even greater um, reduction in the amount of protein that pregnant women from different socioeconomic classes are consuming. So this is a big deal, and I think that this study has a lot of significance. So I'm going to try to make some more videos with other new and relevant studies that I'm looking at from my perspective as a midwife who is interested in biochemistry.